All right, so the last part of section 2.1 talks about creating regression lines, and regression lines are also known as, back from earlier schooling, the line of best fit. And then they're also called least squares regression line. And so we're going to look at it in two ways. One, when we look at creating the regression equations by the lines by hand, it's not as accurate, just because when you're picking two ordered pairs to create the line with, those ordered pairs may not be close to really the line that splits the data in half, and so there's a little room for error there in predicting answers from them. But basically, you would just pick two ordered pairs. What you could do is put it on a scatter plot, fold your paper in half to go through your data diagonally, and then pick the two ordered pairs that are far enough away from each other but closest to that line on the crease of the piece of paper. And that should get you a better approximated line of best fit or regression equation. And then we use point slope formula, which we've done in earlier sections here, where we find a slope between the 2 points, and then we pick one of the points in the slope and put it into the formula, and then solve for y equals mx plus b is what we go through and do. The other way we're going to look at doing it in the technology is enter the data into the calculator using the tables feature. We're going to use the linear regression feature to calculate the equation. And that would be more accurate, and it's going to be more precise and be better to make predictions based off of that equation. Correlation coefficient. Correlation coefficient is what's called the R value. And the R value has to be between -1 and +1. And it can't be anything bigger than that. It's got to be between theirs. It can be equal to +1 or -1. And this tells us kind of how strong our equation is to predict our future values or so forth. It also resembles, in a way, when we look at a scatter plot, how tightly packed the data values are to the line of best fit or the regression equation. One thing we want to make a note is the R value will always mimic the positive negative of the slope when we calculate it. R value matches the type of slope. So if you have a negative R value, that means that your line should be going down, your regression line should be going down from left to right. Match the type of slope. So, and I'm going to put down there positive/negative. Again, you can do it by hand. It's a really big calculation, but when we do this linear regression equation in the calculator, it's actually going to tell us what that R value is. So we'll be able to show you on the screen here as we do a problem. And as we use the R value to help us describe what we see with the data. So I've done this in the past where we start with -1, 0, and +1, and we get to use some adjectives to kind of describe things. And I'm just going to mark off a couple places in between here. So -0.7, +0.7, and about +0.4 and -0.4. And so when we look at our correlation, we're trying to decide, is there a correlation? Does the independent variable, is there a relationship between the independent variable and the dependent variable is what we're trying to see. And so everything to the right of 0 is a positive correlation. Everything to the left is a negative correlation. And then we get to use some adjectives like strong, weak, and then when we get really close, And I guess we're actually gonna move that week over a little bit more. And there's no set thing here, but that would be the week. We could use moderate in here. And then the same thing occurs on the left-hand side. And then we would say no correlation is in this middle part. No correlation would be, there isn't anything correlating the two variables. Can the person's shoe size predict the way they're going to score on the test? The shoe size is not going to dictate that. So there's no correlation there. And again, all those things repeat over here on the left-hand side. So I have some examples here for us to kind of walk through and find this least squares regression with the data point. They want us to plot the data and graph the lines. So this is going with a I wouldn't say less accurate. It just there is some room for error for predicting the equation. So here's my little graph here. Let's plot some points in here. It's nice that they gave them nice and small, so we didn't have to do too big of a graph. 1, 2, 3, 4. Very good. So now as we plot these, -2, 2 would be here. 1, 0 would be there. And then 3, -2. So that would be right about there. Now, as we, it's kind of hard to draw. That's not in a straight line. So we would, if we were on paper, we would crease it, and the line would be something like that. Would be what it is. So what we want to do is pick two ordered pairs. I'm going to pick the two outside ordered pairs and calculate slope with them. So -2 minus 2 over 3 minus a minus 2. That would give me -4 over 5. And then I get to pick one of the ordered pairs and do point slope. So again, that's using this formula here that we learned in a previous lesson. So I'm going to use the last point. Y minus a minus 2 equals -4/5 times x minus 3. And then we would simplify to slope intercept. Y plus 2 equals -4/5 x plus 12/5. We're going to subtract the 2 across. So y is equal to -4/5 x. Subtracting 2 is actually really subtracting 10/5. So that would be plus 2/5. So there's my regression equation, my line of best fit. Typically what we do is we put a little hat on that y, and we pronounce this thing as y hat. And again, and we would refer to this as being the predicted y value, based off of what we're putting in there. Again, we would do the same thing for the second one. Plot the ordered pairs, and pick two to do a slope with, and then create your line of best fit. Now, I'm going to go ahead and just say it right here. We can only use a regression equation to predict values when the new x values are in the range of x values used to create the equation. So we can technically use this equation for prediction purposes, as long as I pick x values that are between the first and last number on my number line. We cannot use it for x values outside of those x values that used to create it. using the equation, or let's change that. Let's just say when an x value is outside the data values used to create the equation, this is called extrapolation. And so we can't use it to help us predict things. So here's, I got a problem. I got a couple problems here where we get to use the calculator to create this stuff. And the first part says conjecture whether the correlation coefficient R for the data will be positive, negative, or zero. So that we can do without putting it in there. What we're going to do is we're going to pay attention to, in a way, the slope. Is the slope positive or is negative? As the x values increase, all right, what is the y values doing? Are they increasing or are they decreasing? Well, we'll notice that they're technically increasing as we're going from left to right. They are increasing. So as that increases, this increases. So that means that we're going to have a positive correlation, which means when I get done with creating my equation, I should have a positive slope. So our R value should be, our R's value should be positive is what should happen here. So I'm going to do a split screen here and pull up the calculator, and we're going to carefully create this equation using the calculator. All right. So we have our calculator. We'll let that thing catch up. We got our calculator here. This is a statistical thing, so we're going to go into the stat button. That's 2 buttons over to the right of the green button. I'm going to press stat. And I want to go into the table features, which is right in this very first function where it says edit. So I'm going to press enter. And I'm going to put all the x values in L1 and then all the y values in L2. So -1, 0, 1, 2, 3. If you're using the Calc 84 app, make sure that you press enter after the last number and make the cell below it become pink, because if you leave the last number with it being pink, it won't calculate it in what we're doing. So now we're going to go over to L2 and carefully type in the corresponding y values for each x value. If you do not, then you're going to come up with some totally different equation. So you got to make sure that we type them in carefully. Remember, do not use the subtraction sign for a negative. It won't like it. And let's see, 7.3. All right, press enter. Boom, boom. So, okay, that's all in there. So we got all that in there. So that's the first step we're going to do. We're going to enter data. Enter data. In L1 and L2. I'm going to press second mode to quit the screen. Second mode to quit the screen. Then we're going to go back into stat. And we want to do a calculation. We want it to calculate this formula for us. So we're going to go to we're going to arrow 1 to calculate. So arrow to calculate. And then we want to do option number 4. So use option number 4. So we're going to press that. And now if you have a calculator that's being reset, it automatically defaults to where L1 and L2 are in those little place values, which is great. We're going to leave the frequency list blank. We'll leave that last thing, store reg EQ, blank. If by chance one of the X list or Y list was something different than L1 and L2 or where you put your data. So I'm going to back it out here. Let's say, for example, it was in L3. So what you do is you'd clear it out and press second and number 1, and the L1 would appear there. If I had my data somewhere else, let's say it was in L4, I can go over second 4, and that puts an L4 there. So you can change where, if you don't put the data in L1 and L2 every time, you can change it to the other columns. So I'm going to leave that all alone and go all the way down is what you got to do on a TI-84 hand, like true calculator. I'm going to hit enter, and that gave me some information right there. So as we pick this information out, the very last thing, the R value, 0.99936, they give us the format of the equation, y equals ax plus b. So they tell us that the a, which happens to be my slope, is 3.25, and the b, which is my y-intercept, is negative 2.45. So that's my slope. That's my y-intercept. So now as I create the equation, we get to say that y hat equals 3.25x, got to put the variable in it, minus 2.45. Now, on the homework assignment, do you have to have that little hat on top of the y? No. I'm sure just putting it down as plain old y is okay. In my statistics courses, we do have to make sure we put that on there. Here's our R value. We said it was going to be positive, and it is. And we would also say this is a really strong positive, is what we get to classify it is, because the closer you are to positive 1, you're strong. You're super strong. So strong positive correlation. Don't think we have a context of the problem. We just have them as x and y, so we can't really describe what's taking place here and describing the slope in the context of the slope. But this at least gets us into creating the equation. And now we can predict things a little bit better with it. And I think that's what we get to do in this last problem, is where we get to create the equation and answer a whole bunch of different questions on those things. So the following table shows mobile devices used usage by BlackBerry or Black Friday shoppers from 2010 to 2015. The middle column lists the percentages of online site traffic due to mobile devices rather than PCs, and the third column lists the percentages of online sales. All right, cool. Identify the trends in the mobile device usage. Well, one thing we could say that in both cases, the percent of site traffic increased and the percent of sales increased. So both, I'm going to get rid of that calculator for the time being and give me some more room here. Both the percent of site traffic and percent of sales increased each year from 2010 to 2015. Good to specify that time frame because that's what we're looking at data-wise. We don't know what happened between 2000 and 2010. We wouldn't have as many. There were cell phones out there, but they weren't like smartphones like they are now. They were the old flip phones, is what they first came out in the early 2000s, is what people used. So you really couldn't do any online shopping and hit the internet. Is there any relationship between the site traffic and sales? Well, there appears to be a positive correlation. Now, why can I say that? I can say that because as we're going to do site traffic is going to be X and the Y value is going to be the percent of sales. We can see as the X column increases, so does the Y column. So that's what I'm basing my statement off of. Is there between those as traffic increases, sales increases. Let X be the year and Y be the percentage of site traffic. So now as we go to do an equation, we are ignoring for number 115, that problem, we are ignoring that column. That column is being ignored, and they told us that this is X and that is now Y as we go to create our equation. So X and that's Y. So I'm going to put the year in 2000 in the X column. So in L1, I'm going to put the year, And in L2, I'm going to put the percent of site traffic. So let's go over here and get our calculator back up on the screen and give it a chance for that to clear out there. There we go. I'm going to get in there, stat, hit enter on edit. I got all this data here, so I'm just going to arrow up to the column header, hit clear, and then when you arrow back down, it goes away, especially when you're using a TI-84. I'm going to go over here to the other column header, hit clear, and it wipes it out. Don't use the delete button when you're doing that because that'll delete the whole column. So now let's put the years in there. So I'm going to start here and put 2010, 2011, 2012, 2013, 2014, 2015. Now, we talked about extrapolation in a little bit earlier. 2016 is right outside our window, so it is okay to kind of use it to make a prediction. Really, probably after 2018, we don't want to use it to make a prediction, and we don't want to do anything prior to 2010, like 2008 or 2007. There's a little wiggle room with how close of the X value do you want to use to predict. If it's right next to one of your data point values that was the highest value, then it's okay. But once there's a little bit of a gap, you kind of stop and hold off. So doing it for 2016 would be okay for us to do. So now we're going to go over here into L2. And now let's put in percent of sales traffic. So 5.6, 14.3, 24. Now the one thing you want to make sure you're consistent on is we're talking about this when we go to explain it in percent. So if you're going to type them in as like decimals, like 0.056, make sure you compensate some form or fashion. And then 49.6 and 57.2. All right, I got all my there. Good, I got my cells even. That's a key thing. So now we're going to quit our screen, second mode, go back into stat, go over to calculate, go to Lin Reg, option 4. We got the stuff in L1 and L2. You scroll down if you're using a TI-84 hand calculator, scroll down to the bottom, hit enter. I'm going to hit enter right now. And this is for number 15, for 115. That's with the problem number 1. They tell us our R value is 0.9953. That's really good. That's a nice strong positive. That's very nice. My equation, they tell me my A is 10.8457. B is negative 21.79, or sorry, 21,795.266667. One more 6 and then a 7. So as I write my equation, and again, the more decimals we use, the better. Do they tell us to? So when we go to use this prediction, we want to use all those decimals is what I prefer to do. So here's our equation. It is y equals 10.8457x minus 21,795.266667. And that should get us pretty accurate. So now we want to predict for 2016. So our prediction for 2016, we get to put the X to 2016 in for X. So 10.8457 times 2016 minus that big number there, 21,795.266667. All right, so we're going to go to handy dandy calculator on that one. I'm going to do it all in one fell swoop here. All right, so 10.8457 times 2016, and then I'm going to subtract off 21,795.266667. And my answer is the predicted usage for 2016 is 69.6645. So 69.66%. That's the predicted usage based on that model. I don't have to move the decimal because, again, I left everything in the as normal numbers and said, hey, it's saying it's percentages. So that's 115. 116, let X be the year again, Y be the percent of sales. Use the regression model and use the first and third columns. Okay, cool. So what we're going to do is we're not going to clear out our what we have. So we're going to hit Stat, and we're going to go into Edit. We're going to leave. Oops, sorry, add. Sorry about that. I know that's why you felt this past week with my class. We just had so much homework to do. And hey, there's a math tutor if you don't want to use MTSU with the tutoring. So I'm going to leave L2 alone, and I'm going to go into L3, and that's what it's telling us to put down the last column of data there. So I'm going to put in 3.2, 9.8, 16.3, 21.8, 27.9, 36.2. So I got all those in there. I'm going to hit second mode to get out of that screen. Again, they want me to come up with that regression equation, so I'm going to hit Stat, go over to Calculate, option number 4. Now, I want to use the X list of L1, but my list I want to use for the Y list is in L3. So I'm going to go to that Y list, and let's get down there with that. And I'm going to hit Delete and delete that out of there. I have the stuff in L3, so we do second, and then the number 3 puts the L3 there. You can see the little faint blue L3 above the number 3 there. Then arrow down to Calculate, and then hit Enter. And then I'm just going to go ahead and hit Enter, and carefully to scroll. And I'm going to change colors here. Let's get a different color. So this is number 116. We found the R value was, again, nice and strong, 0.9984. My A was 6.42286. And my B would be negative 12,906. And then 8 with a whole bunch of zeros. Now, we don't have to put in all those zeros. So that works out pretty good. So my equation, y equals 6.42286x minus 12,906.8. And then now let's find the prediction. What's the prediction for percent sales on in 2016? So 6.4286 times 2016, subtract off 12906.8, and that predicts it's going to be 53.2576, so 53.26%. That is going to be the percent of sales in 2016. All right, going over here, let's see what number 117 says. Let X be predicted traffic site and Y be, so we're using the second and third columns on this one. Come up with a new equation. And then predict the percentage of sales if the site traffic were to reach. Predict. Okay, so if it were to reach 70%, so that's going to be my X value that I plug in. So that right there, that is my X value when I go to type in, once I get my equation. So let's go back here. And again, what's nice about using the calculator is we got all that data in there, so it's really just repeating that linear regression thing and just making sure we have the column set up right. So we're going to go to Stat. We're going to go to Calculate. We're going to go to LinReg, and then now we said that I want my X list to be column 2. So I'm going to get rid of that and put in second 2, and then I want my Y list to be column 3. So second 3. And then now I just hit Enter. And there's my information. So let me get a pen here and let's use orange. So for 117, we found out that my R value is 0.98923. That's nice. That's still nice and strong. My A is 0.584009, and my B is 0.667449. And now let's create an equation. Y equals 0.584009x. That was a positive B value, and so plus 0.667449. And then now we're ready to figure out, okay, what's the predicted for 70%? So 70, we're going to put in a 70 in there. So 0.584009 times 70, add to it 0.667449, and hit enter. And 41.548079, so 41.55%. So the predicted sales, if the site traffic were 70%, the predicted sales, that's my predicted sales, would be 41.55%. So on 118, they want us to interpret the A value. So they want us to interpret the slope. So here's my slope. They said going back using 117 slope. So for problem 118, A is equal to 0.584009. So they want us to interpret it in a sentence. So here's how I would go about doing it. We know that's the percent sales for each percent traffic, if the percent of traffic, was at a percent of traffic. So the percent of sales increases, because it's positive, increases 0.584009, increases, the percent of sales increases that for each 1% increase in site traffic. So that's using the context. We have the percent of sales will increase by about 0.58409 for each 1% increase in site traffic, because again, that's technically over 1 when we think about it being slope. If it's a whole number or a decimal, we would just say it's over 1, and so that's where I got the 1% increase in site traffic. That should be it. Again, I'd go back and look at that and replay it a couple times. Calculator is very handy as we're going through and trying to create these equations.